Hello AFDA students, this video is going to explain how I create the example project. So you need to start by finishing the sentences on the top. Okay, and then we need to get the data from the student survey. So you're going to choose one of the questions and we're going to figure out how many people said each of these. So how many people chose 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So going back to your student data, my question is question 41. Okay, so I'm going to count all of the numbers. So 0, okay, so I went through and I counted how many people chose each number from the student data. All right, so now I need to find the mean and the standard deviation, and we're going to find this in the Google spreadsheet. So going back to the student data, I'm going to make a copy of this because you won't be able to edit this if you don't. So go to File, make a copy, and you can call it whatever you want. It can be copy of, that's fine. And then this is your copy, so you should be able to edit it. So you need to find the question that you're working on. And we're going to highlight all of your numbers, just your numbers, nobody else's, like that. Okay, and then we want to do functions and average. Average is the mean. Okay, and it says, is this what you want the average of? This is what I want the average of, so I'm just going to press enter. All right, and it gives me the average there. I'm going to round it to one decimal place, so 4.3, because that 8 means the 2 rounds up. So the mean is 4.3. All right, I'm going to now do the standard deviation. So what I'm going to do is delete this, and I'm going to highlight all my numbers again. And then this time I'm going to go into the functions, and this is a little bit harder. I need to go to the statistical menu, so go use the bar over here on the side to the statistical menu. And now I need standard deviation. These are in alphabetical order, so I have to scroll down to standard deviation. Remember, you want just STDEV, none of the ones with extra letters. And it's asking, is this what you want? And I'm just going to press enter. All right, and my standard deviation rounded to one decimal place would be 2.6. All right, and then we're going to make a histogram, which is a graph, and the histogram is going to show us whether or not the data look to be normally distributed. Remember, normally distributed would mean that it kind of looks like this bell curve here. So going back, I'll delete this number just so I don't accidentally use it. And I'm going to highlight my numbers again. And this time I'm going to insert chart. And this is not the chart I want. I'm going to go back to chart type. Now it's asking me here histogram, but that's because I've done one before. So you might not have that choice there. You might need to scroll down to other, and under other, if you just hover over this one, it says histogram chart. Okay, and so then if we look over here, we can see between 0 and 2.1 people, let's see. Oh, sorry. We have about 9 people gave an answer between 0 and 2.1. 10 people gave an answer between 2.1 and 4.2. So it's not completely symmetric, but there is a peak over here. And what we're going to do is go over here to copy the chart. And we're going to paste it in here. I'm going to paste it unlinked. And you can resize it if you don't want it to take that much space up. And it fit on the page, that's nice. All right, so now what we're going to do is use our mean of 4.3 and our standard deviation of 2.6. And we're going to edit this normal distribution. So I'm going to double click on it. And I did create some text boxes below, so I should be able to use those. So remember, the mean goes in the middle, 4.3. And then I'm going to add standard deviation of 2.6. So that should give me 6.9. And I'm going to add 2.6 again. Okay, so I put the mean in the middle, and I added 2.6 each time to get these numbers. And then I subtracted 2.6 and subtracted 2.6 and subtracted 2.6. So if my data were normally distributed, it would be in a curve like this. All right, so now I'm going to find the z-score for students who chose 5, the neutral answer. And the z-score, remember, is x, your number, minus the mean over the standard deviation. So in this case, your number is 5 minus the mean, which was 4.3. Oops, that was not a point. And that's going to be over the standard deviation, which was 2.6. All right, so I need to find that answer. I'm going to use Desmos. All right, and I'm getting a z-score of 0.27. Okay. And then using the z-score table, I'm going to find the percent of students who disagreed, which means they chose less than 5. So I'm looking for 0.27 on the z-score table. I need to scroll to the positive side, 0.2, and then I go to the column with 0.07. So I'm going across, and it looks like I'm right here, 0.60642. All right, if I want to make that a percent, I need to multiply it by 100, which will move my decimal place over 2 places. So it's going to be 60.642%. All right, so it looks like a lot of people disagreed. And then if this is the percent less than 5, then the rest of it should be greater than 5. Now, that doesn't make complete sense in our case because some people did choose 5, but when you're doing the normal distribution percentages, then it's either going to be less than or greater than a number. So we're going to do 100 minus. And we're going to get that answer. All right, so now we're going to find the actual number, or actual percent of students who agreed. So let's go back up to your table. All right, so remember the people who agreed were the people who chose 6, 7, 8, 9, and 10. So I'm going to add up these numbers. How many people chose this? So that gives me 8, 10, 11 people out of 35 AFDA students. That's how many really agreed. And let's let's divide that to find your percentage. Oops, I missed a 1. Okay, so that looks like 31.4%. Okay, so you can see that these numbers are a little bit different. Part of the difference is probably that this one does not include 5s, and part of the difference is probably that the data are not actually normally distributed. You can look at the shape here and you can see it's not really symmetric. There is a peak, but the two sides are not symmetric. All right, so these numbers are not that close. So I'm going to say are not very close because the data are not normally distributed. Okay. Responses to the teacher survey. So now I'm going to go through the same steps using the teacher survey. We split the survey in half for teachers so that they wouldn't give up and not answer it. And so there are different numbers depending on whether you were on the first survey or the second survey. So you need to look at the survey where your question is. And that's not mine. This one's mine. And see, the first row is the question. So the first row is not actually an answer. I'm going to scroll down and see how many teachers actually answered. Okay, so I'm on row 27, but the first row was an answer. So that means 26 teachers answered my survey. Okay, and I never filled in my question, did I? I need to copy my question. All right, so my question, sorry, let me go back to my teacher survey. So my question is at the top. And remember, you chose just one of your questions for this. I don't need the number 41, so I'm just going to copy the words. And I'm going to put it here. And I'm also going to put it down here. All right, and then I need to go in and start counting how many people said 0, how many said 1, 2, and etc. Okay, so I counted how many people chose each number, and now I'm going to find the mean and the standard deviation, just like I did before. All right, so I need to make a copy of this. And then I'm going to go over to my data and highlight the numbers and go to functions, average is the mean, and press enter. So 3.2. And the standard deviation. So I'll delete the mean and highlight again. Functions, and then I have to go to the statistical menu and standard deviation. Oops. And press enter. That's going to round to 2.5. All right, and then I'm going to make a histogram of the results. So delete this one and highlight the numbers again. Insert, chart. All right, that's not what I want. I'm going to change my chart type by scrolling down to Other, and here's the histogram. All right, so looking at this histogram, again, even though I have a peak in the middle, it does not look to be normally distributed. It's not symmetric on both sides. I'm going to copy it and put the histogram under here and paste it unlinked. Resize it. Okay, and then we're going to do the curve again. So this time I have a mean of 3.2 and a standard deviation of 2.5. So double click it and put the mean in the middle, 3.2. And then we'll add 2.5 to get the next number. And add 2.5 again. Okay, and then on the left side, I subtracted 2.5 to get each number. All right, so if my data were normally distributed, then this is the shape that they would have. I'm going to get rid of some of this empty space. All right, so the z-score for people who chose 5. So the percent of teachers who disagreed would be from the z-score. So I'm going to go back and grab that formula for the z-score. Your number minus the mean over the standard deviation. Okay, so your number is 5. And the mean was 3.2. And the standard deviation was 2.5. Let's get an answer for that. Okay, so I get 0.72. So my z-score is 0.72. And then to find the percent of teachers who chose less than 5, I'm going to use my z-score table. So I'm still on the positive side from before. 0.7 is here. And then I find the column with the 0.02, it's right here. So 0.76424. Okay, and to make that number a percent, you multiply by 100, which moves the decimal over 2 places. So I get 76.424% who disagreed, and that means the number that agreed would be 100% minus that. Either you agree or you disagree. Of course, it's a little imperfect since we gave people the option of being neutral. Okay, so if my data were normally distributed, then I would have 23.576% of teachers agreeing. The actual percent of teachers who agreed, let's go look. All right, so 5 was neutral, and these are the numbers that agreed. So only 2 teachers agreed out of 26. Now remember, you might have 26 or you might have a different number, so make sure you're paying attention to your numbers. Okay, so the actual percent would be 2 out of 26, and I need to find that number. Okay, so I'm getting 0.077. which is going to be, to make that a percent, you move the decimal over 2 places, so 7.7%. So that's very different from 23. So these numbers are not close. Oops, are not close because the data are not normally distributed. All right, so let's make some conclusions. So the question I asked is, do you agree with the statement our school colors should be purple and gold? And looking at the student data, from the student data, 31.4% of students agreed. And so I'm going to put that in my conclusion. 31.4% of students agreed that our school colors should be purple and gold. But only 7.7% of teachers agreed. Looking at my normal curves, I can see that people's answers are pretty spread out because the answer choices were actually only 0 to 10, but you can see these normal curves actually even go farther to negative numbers and above 10. So I had a standard deviation that was pretty big, which caused these numbers to go past 0 to 10. And that tells me that the data is pretty spread out. So I'm going to say that people's opinions are very spread out because my standard deviation is so large that the normal curve is labeled with numbers below 0 and above 10. Okay, and looking at the histograms, I can see the teachers feel pretty strongly that the school colors should not be purple and gold. You can see most of the teacher answers are over here. Students also seem to disagree with the statement pretty much, but there is some agreement here. So I'll just conclude that too. From the histograms, I see that students and teachers mostly disagree with my rule change. Oops. Suggestion. Okay. And I think we are done with our project.